Okay. To kind of review get our brains back in gear here, we're going to take some derivatives, basic derivatives, and then a couple of basic antiderivatives, and then we'll get into U substitution, which is for complicated antiderivatives. But before we do complicated antiderivatives, we should probably do some relatively straightforward derivatives. And I'm trying to leave room to do two derivatives, and then beneath that we'll do two antiderivatives, just to get our brain back thinking about calculus. So, first two warm-ups, take the derivative of the sine of x squared, and take the derivative of secant of 4x. You go one layer at a time, and derivative signs cosine, but then we leave the x squared alone, and then we chain onto that, may see the derivative of x squared, which is 2x. Okay, Zainab, how about the derivative of secant? Okay, this is good, but this is where some people messed up. Secant tangent, true. Secant of what? Tangent of what? But the argument has to stay the same. So secant of 4x times tangent of 4x. And then, Lauren, what else do we need to put on the end of this? Times 4. So the chain rule, times 4. All right, that was a little rough, but that's okay. It's been 2 or 3 weeks since you've done any calculus, so no big deal. Let's now do a couple of antiderivatives. Force you to go backwards a little bit here. Antiderivative of x squared and antiderivative of secant squared. Naomi, what's the antiderivative of x squared? 1/3 x cubed plus c. Yes. Increase the power by 1, divide by the new power. Don't forget the plus c. That's the power rule. I like the power rule. The second one's not a power rule. It's a trig thing. So, Andrew, what function has a derivative of secant squared?
Tangent x plus c.
Good. Tangent of x plus c. Okay. Hopefully our brain is now at least somewhat warmed up with taking derivatives, moving forward with the product rule and the chain rule and the quotient rule, all those things, and then going backwards, Luca, with the antiderivatives. But you might notice that the antiderivatives I gave you are easier than the derivatives I gave you because there's not a chain rule for antiderivatives. For derivatives, we know the chain rule, not bad. For antiderivatives, there's not a chain rule, so I can't yet, anyway, give you anything that's too complicated to go backwards with. Well, I'm glad you came today because U substitution will allow us, it's the integration equivalent of the chain rule. So U substitution will allow us to go backwards. It helps us undo the chain rule. Undo the chain rule. That's what we're doing today. Undo the chain rule. So going backwards using the chain rule, but you don't have a chain rule, so U substitution is what we use to undo the chain rule. It allows us to integrate more expressions. The U is arbitrary, meaning you can pick D or W or any letter you like substitution. But every book calls it U substitution. So if you called it something else, people would look at you funny. Okay, a key to remember.
Document 40 in this bill. Please take attendance at this time. Thank you.
Okay, so back to U substitution. Allows us to go backwards. The key thing is that you have to replace all x expressions with U expressions. So all the x's have to be gone and replaced with U stuff. The most important step of U substitution is picking U correctly. So you have to know how to pick U, and the best way is just more practice, practice, practice. But there are a couple of hints on how to pick U. There's 2 hints when it comes to picking U. And the hints alone aren't enough, but the hints plus practice, you'll get there. You'll figure it out. The main point to picking U is that we want to simplify the integrand. Simplify the integrand. Remember, integrand is just the fancy word for whatever we're taking the integral of. So we're using U substitution to make our life easier. That's the main point, is rather than have to, I mean, you can kind of look down the page and you're like, those are all terrible things to have to integrate. But if we do U substitution on them, we will get easier answers. The second hint is that we want du to show up. It's not very technical, but you'll see what I mean in a minute. So we pick U to simplify the integrand, and we also want to pick it so that du is also in there somewhere. Again, it probably doesn't make much sense till we do a few of them. Okay, so looking at number 1, it looks like it needs a product rule, but there is no product rule, so we're going to use a U substitution to make our life a little easier. If I let U be x squared minus 1, then that simplifies the integrand. I don't have x squared minus 1 in there, I just have U to the 5th. Still have the x out there, we'll worry about that in a minute. So that would simplify what I'm trying to take the integral of. But I can't stop there because I have to replace all the x things with u things. So I still have an x, still have a dx, so this isn't enough. It's a good start. Every time you pick u, immediately after that you'll pick out du and see if it works. So what's du? Usually du is really not that bad. Alina, what's the derivative of x squared minus 1?
X squared minus 1, 2x.
2x. Now, I'm only going to do this once because we skip over this step. Really, we should say du dx is 2x, which means du is 2x dx. We're not usually going to show that middle step. We're going to jump straight to du with the dx on the end of it. Okay, so I'm looking at my integrand. I got the x squared minus 1 taken care of. The 5 thing, I know how to integrate that, so that's fine if that's there. This is, what's left is x dx, which I guess is close to 2x dx. It's not there exactly. Well, you can do kind of a trick. At first it's going to look illegal to just stick a 2 right there. Maybe that seems not quite right. And if that's all I did, that's not right. You can't just go stick a 2 somewhere because it makes your life easier. But I could put something else somewhere else to sort of balance the 2 or to counteract the 2. Any thoughts on what else I could multiply by that would cancel out the 2? It's easier than, oh, you can see from there. I'm going to put a 1/2 out front because the 1/2 and the 2 would cancel each other out. No, but the reason I did that is now I've got 2x dx, which is the same thing as du. So the 2x dx combines to make du. We already replaced x squared minus 1 with u. That 5 is still there. And there's now a 1/2 out front. But now I've got a much, much easier thing to integrate. But before we integrate, let's pause. Do you see all of those substitutions I made to get there? not say so. It started with letting u be this thing to make things easier. Then dx and du kind of showed up when we were able to get du into the problem. And now we've got what I hope is an easy antiderivative problem. Nick, what's the antiderivative of u to the fifth? I'm going to leave the 1/2 there. What's the antiderivative of u to the fifth?
5. Oh, the antiderivative?
The antiderivative, careful. You almost said 5u to the fourth, because that'd be the derivative.
Would be 6. U to 7. Or,
So you're on the right track. You do want to increase the power by 1. It has, that's okay. Increase the power by 1. But if I took that derivative, there'd be a 6u to the fifth. And I don't want
over 6.
so over 6. And then plus c. We're still not quite done because this started as an x problem, not a u problem. So we need to go back and put the x stuff back into the u, in for u. So 1/12 x squared minus 1 to the 6th plus c. Now, not that anyone would, but if you wanted to check that, you would take the derivative of this thing, and you should get back to where we started. And I think you can kind of see that. You'd bring the 6 down front, then you'd have x squared minus 1 to the 5th, and then you'd multiply chain rule by 2x, and you'd get right back where we started. So the u substitution took this from a really weird, ugly problem to a fairly easy problem. When you do u substitution right, usually that last step is pretty easy. All the work goes into fixing the u and du stuff. All right, I'm not going to pick on anybody yet because it's only the second one, but any thoughts on what you think u would be for number 2? Somebody said it. Yeah, 6x minus 1, Kyler. Because that would make at least part of this a little easier to deal with. So all of this stuff would be u. The 2/3 is fine. I know how to undo a 2/3. But now I need to worry about the du dx business. So Danny, what's du?
60.
Nice. I like that you included the dx on there. 6 dx. So the derivative 6. The dx is usually on the other side, but we need it on the right side, so we kind of move it over. Okay, so close, kind of. I want 6 dx. Instead I have 4 dx. There's a couple ways to get there. One way is, what would I multiply 4 by to get to 6? 3/2. So some people are going to do 3/2 on the outside, or 3/2 on the inside, and 2/3 on the outside. Other people who maybe aren't as good at fractions are like, you know what, I don't want to try to figure out what it takes to get from 4 to 6. I'm just going to put the 4 out front. And then I want a 6 on that dx, so I'll put a 6 there. And if I put a 6 there, I need a 1/6 out front. So you still end up with 2/3 out front, but maybe that was a little easier than figuring out how to get from 4 to 6. Okay, I kind of don't like what I've written. It's not wrong, but there's nothing you can do with that because you've got u's and x's in there. So I need to change or replace this 6 dx with du. 2/3 antiderivative u to the 2/3 du. And again, we went from a really awful antiderivative to one that's hopefully not as bad, hopefully fairly straightforward. Julius, how about the antiderivative of u to the 2/3?
3/2 u. No.
Good catch.
5. No. 3 over 5.
Yes?
5.
Yes. 3 over 5, u to the 5/3. Plus c, a little bit of algebra cleanup, the 3's will cancel. So 2/5. And then let's put that u stuff back in there, 6x minus 1 to the 5/3 plus c. U substitution. It's a little bit of work, but it makes a really hard integration problem into what hopefully is an easy integration problem. Number 3. I'm not sure I want to start calling on people yet to pick u. Any thoughts on what u should be? What u? Any guesses? I'm not holding it against you yet because it's still early. We have to be careful. If you make u too complicated, okay, so that would greatly simplify the integrand if you let u just be all of that. But then du would be a mess, and it really wouldn't help. So you have to be super careful. You want u to be enough stuff to make life easier, but if you make u too much stuff, then du gets to be a mess, and it doesn't help. So it's always a line of how much can I let u be without blowing this problem up. And I definitely don't want u to be all of that, because then that would be a mess. In fact, even if I let u be the entire denominator, that would be a mess. I think I want u to just be 2x squared minus 1. Because I can handle a cube root. I can integrate that. Right. Leah, if u is 2x squared minus 1, then du is...
So then D would be just the rest of the x times the numerator.
Well, it is going to end up being the numerator, but we don't want to look at that. We just want to look at this. So what's the derivative of 2x squared minus 1?
Oh. Would just be. I'm so honest, I'm blanking. I have no idea.
So power rule, bring the 2 down, decrease the power by 1.
4x.
So 4x dx. Now, you were right to be peeking ahead at the numerator because we were certainly hoping it would match something in the numerator. And we're pretty close. Just need a 4 and a 1/4. So let's see what we've got here. A 1/4 out front, antiderivative.
I'm sorry, where do you get the 4 and the 1/4?
Okay, good question. I put the 4 in there because I wanted all of that to match so that I could replace it with du. So I sort of forced the match, and the cost for forcing the match was a 1/4 out front. Let's see, cube root of u. All right, my next question is an algebra question, not a calculus question, Sophie. I don't like doing antiderivatives of roots. I'd rather do antiderivatives of powers. So how could I rewrite the cube root of u in the bottom as u to some power? What would the power be?
You don't want to move it up to the numerator, right?
I do, because I want a power. I don't want a root.
U to the negative 1/3.
So I want u to the negative 1/3. And I guess in some sense, up until calculus, we don't like negative exponents. But in calculus, we would definitely rather a negative exponent than something in the denominator. Okay, so that was a lot of work to get there, but now I should have a fairly straightforward, I'm calling it that as I call on Audrey to tell me what the antiderivative of u to the negative 1/3 is.
3 has negative 2.
No, you're doing it right. Increase the power by 1. It's 2/3. and divide by 2/3. That's where the 3/2 came from. Plus c, so 3/8, and then we'll put that u and x stuff back in there. 2x squared minus 1 to the 2/3 plus c. So kind of an ugly start, kind of an ugly finish, but the middle was cleaned up with the u substitution stuff. All right, it's time to put people on the spot. And I kind of hope someone guesses wrong, because a lot of times when we start doing these, you guess u wrong first, and then you take du and nothing works, and so you got to go back and try again. Angelina, having said that, what do you think we should try for u?
X squared plus 4x minus 3.
I think that's a good pick. I think if we included the squared on that, things would get too complicated. So I like that you picked that. Let's see if that works sort of with the rest of the problem here. So I need to figure out what du is, and hopefully it's somewhat close to dx. Kyler, what's du? 2x plus 4 dx. So, Naomi, would you say that's good news or bad news for du? What we got for du? Good news? It's not perfect news, but it's good news. How do I make it work? Got that. We're close to matching. If we just put a 2 out there, then it all matches up. Of course, I got to put a 1/2 out front now. Okay, so I forced the du match. So that's du. Still got a 1/2 out front. And in the bottom, I've got u squared. Again, I don't like antiderivatives of denominators. I'd rather write that as u to the negative 2. And then have Shelby tell me what the antiderivative of u to the negative 2 is. Negative 1, u to the negative 1. U to the negative 1 divided by negative 1. So negative 1/2. And then let's put the x stuff back in there. X squared plus 4x minus 3 to the negative 1. Almost forgot the plus c. That's an acceptable answer. I suppose in a multiple choice setting, they might move that to the denominator like that, but those are the same thing. So either one. Again, the first one's a great free response answer, maybe cleaned up in a multiple choice setting as the second one. All right, 5 and 6 are kind of ugly. We're going to come back to those at the end. Number 7. Oh, we've got some trig in number 7. Any thoughts on what u should be for number 7? I'm still new to this. I'm hesitant to pick on somebody. Any thoughts? Any guesses? Somebody give me a guess. What do you think? I want to simplify the integrand, but I don't want to pick too much because then it won't work. Just the 4x. I don't want to do cosine 4x, because if I do cosine 4x, then du has a sign in it, and I don't have a sign, so yeah, let's just let it be 4x. then du is 4dx, which that's not bad. I can just put a 4 on top of or in front of the dx and a 1/4 out front. And now I don't have the 4 to worry about anymore. Now it's a little more straightforward. Callie, what's the antiderivative of cosine of u? Sine of u. So 1/4 sine, and then I'm just going to replace that on the fly here. Sine of 4x plus c. After we do a few like that, some of you are going to skip over all the u substitution business, and you're going to be like, look, the antiderivative of cosine is sine, I know that, and then I've got to fix the 4 thing, so a 1/4 out front would fix it.
Why don't you add 4 like in the equation? Like you have that. Like,
So I put it right there. Kind of put it in a weird spot, I guess, but there's my 4dx to make this work. To turn that into du.
okay.
Right, 8's pretty similar. What's the answer? Or what do you want to use for u? I can pick on somebody. This is a similar question here. Dana, what do you want to pick for u for number 8? 10x. So du is 10dx. So that's an easy fix. Just put a 10 on the dx and 1/10 out front. And we did something like that earlier. We've seen that. It wasn't exactly in that format. Kinley, what's the antiderivative of tangent of u, secant of u? Secant of u. Then we'll put that 10x back in there, and don't forget the plus c. And another one where some people are going to skip over the u substitution stuff. They're going to be able to jump straight to the answer. Turn the page. We'll come back to 5 and 6 in a minute. Number 9. I got sines and cosines in my integrand. Again, I want to pick u to simplify my integrand and so that du will show up. So, any thoughts on what u should be? What did you say, Julius? Let's just make it sine of x. If you include the cube on that, then the derivative would be 3 sine squared times cosine. That'd be a whole lot more than we have to deal with there. So let's just let u be sine of x. So we've got u cubed. That's no big deal. We can handle a cube. Marie, what's the derivative of sine of x?
Dx.
Good. Cosine of x dx. Well, that one works out real well. We don't have to do any extra stuff to make that work. So another one that started out looking terrible, with the right pick for you, got a lot easier problem to work. Owen, what's the antiderivative of u cubed du?
U to the 4th over 4.
U to the 4th over 4 plus c. So I'm going to go 1/4 and then put sine of x back in there. 4th plus c. That would be an easy one to check going backwards. Right? The derivative of 1/4 sine to the 4th. The 4 would come down and cancel the 4th. That would leave you with sine cubed, and then chain rule is where the cosine would come in. So this is a good one to see how u substitution sort of undid the chain rule. Number 10. Another trig one. Again, you got to know your rules well enough to pick u so that du shows up. So do you want u to be tangent or do you want u to be secant? Which would be a wiser pick? Well, let's think about what's the derivative of secant? Secant tangent. So I don't think that's what we want. What's the derivative of tangent? Secant squared, and we do have a secant squared. So let's let u be tangent of x, du be secant squared of x. And the further we go, the more often this kind of thing happens. You can't really tell right away, so you pick one, you start working. If it doesn't work out, then start over and pick something else. Let's see, secant squared dx is du. U is tangent, so that squared is still there. But that's no big deal. I can handle a squared. Or Bailey can handle a squared, I should say. What's the antiderivative of u squared?
That is going to be u to the third power over 3.
Plus c.
Plus c, yeah.
So 1/3. U was tangent, so let's put tangent back in there. Tangent cubed of x plus c. Another one where the taking a derivative of that using the chain rule would be easy to see what we got. Okay, let's flip back to those. Oh, you don't know they're tricky yet, but I know they're tricky. 5 and 6. They're tricky in the same way, so let's see where we land. Okay, so what is that one like this? Any guesses on what you think u should be? What do you think? What would be most helpful in starting to simplify that integration? In my mind, there's only two options that I think I see: x plus 2 or x minus 4. Which thing would you rather clean up? X minus 4. Like, you would rather have a cleaner square root. So let's let u be x minus 4. Alright, so that's u. Du. Warren, what would du be? What's the derivative of x minus 4?
X dx. Or 1 dx.
1 dx, or just dx. So that's good news. That means this is du. The trouble is, I've still got this x plus 2 out front. So I fixed this thing, but there's still some x stuff hanging out there. And I can't integrate if I've got x's and u's. So I really need to replace x with something. And I don't want to do, like someone suggested, a different substitution. Like, let's let v be x plus 2. Like, well, then you still have two variables to deal with. So I need to replace x with something I already know something about. So what does x equal based on what we already said? I'm going to rephrase that, but yes, u plus 4. So in place of x goes u plus 4. Plus 2 is still there. Now we got the square root of u du. Okay, that's kind of ugly, but we've got it all in terms of u. So let's see, u plus 6, square root of u du. There is no product rule for antiderivatives, so I can't do anything yet. I need to algebra first. So I'm going to distribute this square root of u. And Luca impressed me with your algebra skills here. U times the square root of u. What would that be? Especially if I only want one power up there. I don't want to write it as u square root u. I want u with one power. U times square root of u. But I don't want to leave it as u squared root of u. I'd rather write it with powers.
So would it be u to the 3/2?
There you go. That's what I'm looking for.
Oh, yeah, you just said it.
Ethan, how about 6 times square root of u? What would be a better way to write that for calculus purposes?
6 times square root of u.
So let's do u to the 1/2. Now I've got things I can take antiderivatives of. So increase the power by 1, that would be 5/2, and then 2/5 up front. Increase the power by 1, that'd be 3/2, and a 2/3 out front, plus c. But I'm not done, I gotta put that x stuff back in there, so 2/5 x minus 4 to the 5/2 plus 12 divided by 3 is 4, x minus 4 to the 3/2 plus c. That's like that extra level where you have to use that reverse double back substitution thing from number 5. We'll start number 6. I don't think we'll finish it, but we can start it. What do you think u should be for number 6? X minus 6. Du is just dx, so we got that taken care of. We got this taken care of. But the top is messed up. Maybe. What does x equal? I'd like to replace that top x with something. U plus 6. And then the plus 6 minus 5 would be u plus 1 over square root of u times du. And so we finally got everything in terms of u. And I'll stop there so that I'll have time to pass out the worksheet. All right, today's